It's hard to believe that this is the end of the semester. So today we'll be reviewing for your final for intermediate algebra. This is an old final that we've given before at our campus. And normally our finals are departmental, made and given across to all the students. But because of what's going on this semester with the coronavirus, that's not going to be the case. Your final will be on my math lab and will be available to you at start of the time. So let's just go through the problems here. So right here, it says the first step of the 8 problems, simplify the following expressions. So first of all, just realize that they said expressions and not equations. So we're not solving for any variables here. We're just simplifying and doing order of operations and properties of what we're dealing with to simplify. Then it says write your answer in the space provided, rationalize all denominators, write complex numbers in the form a plus bi. Each problem in this section is worth 3 points. Well, that doesn't matter to you about points. Okay, so here we have 3 square root of 2, all times the quantity root 10 plus 5 square root of 8. So we need to distribute 3 square root of 2 here. So let's just recall a couple of properties here before we do that. So recall properties of radicals. If we had the square root of a times the square root of b, recall that this is equal to the square root of a times b underneath the radical. So we can go back and forth this way. There is a stipulation that a and b cannot both be negative. If they're both negative, then we need to pull out the imaginary part first before we can multiply underneath the radical. Okay, so we're going to distribute our 3 square root of 2. And so we have 3 square root of 2 times square root of 10. So using this property, we have 3 square roots of 2 times 10, so 20, plus 3 times 5, so 15 square roots of root 2 times root 8 is 16. So we want to pull out as much as we can, and I notice that square root of 20 has a factor that is a perfect square. And that's the same thing as 4 times 5 underneath the radical, plus 15 times, well, the square root of 16, that is just 4. And so we have 3 times, well, the square root of 4 here underneath the radical is 2, root 5, plus 15 times 4. So that is going to give us 60. And so if we simplify this, we have 6 square root of 5 plus 60. We cannot combine those terms. In order to add terms with radicals, they have to have the same number underneath the radical and have the same index. In this case, since 60 doesn't have that root 5, we can't add them. Okay, so now we want to look at the following. The square root of the fraction x to the 6th power times y to the 3rd power all over 12z. So there's another rule for radicals that says if you have the square root of a fraction, a divided by b, we can break this down, and if it's helpful, sometimes it's helpful to go the other direction, but we can break this down as the square root of a or the square root of b. Okay, so looking at this, I notice that this is the same thing as the square root of x to the 6th, y cubed, all over the square root of 12z. So in the directions, it told me that I needed to rationalize my denominator. So I want to get rid of the radical in the denominator. I can do that, start working on that now, or I noticed that there is a factor of 12 that I can pull out. And I also notice in my numerator that I can break this down. So the square root of x to the 6th, well, you're thinking to yourself, what can you square to get back x to the 6th? Well, you can square x cubed to get back x to the 6. And so the square root of x to the 6 is x cubed. I notice that I can't pull out the square root of y cubed, but I can break it down just like I'm going to do for that square root of 12. So y cubed, using the rules of exponents, I can break this down as y squared times y all over the square root of 12. Well, 12 could be broken down as 4 times 3, and then I also have that z underneath the radical. So pulling out what I can, here we have square root of y squared. So far we have x cubed. Square root of y squared is y. And then we have the square root of y. There's a single y left underneath the radical. The square root of 4 is 2. And then I have the square root of 3z. Okay, so in order to get rid of the radical in the denominator, I need to multiply this by a fancy one, what I call a fancy one. And so because it's a square root, we need 2 of each factor underneath that radical. And so I need 2 3's and I need 2 z's. Right now I only have 1 3 and I only have 1 z. And so in order to do that, I can multiply both the numerator and denominator by the square root of 3z. Okay, so doing this, we have x squared, y, square root of, so again, using our property that we first talked about, square root of y times the square root of 3z, we can put all of that underneath the one radical, so this could be written as 3yz. All over 2 times, well, the square root of 3z times the square root of the 3z is the square root of 9z squared, or just 3z. And so I'm almost done. I just need to simplify this a little bit, and I can do that. The numerator, I would have x squared y, square root of 3yz, all over 6z. Okay, so for the next problem, we have the following: 2x minus 6y all over 7x squared divided by the quantity 3x minus 9y, that all divided by 14y. And so when we have division of fractions, we want to rewrite that as a multiplication. So we're going to copy down the first fraction and rewrite it as multiplication of the reciprocal of the second fraction. While I'm doing that, I'm also going to be factoring. So notice that we can pull a 2 out of our numerator, and so if we factor out a 2 from our numerator, we're left with x minus 3y all over this 7xy squared times, so flipping the second fraction, 14y we have in our numerator, and then in our denominator I'm going to pull out a 3, and pulling out a 3 I'm left with x minus 3y. So now that it is a multiplication problem, we can start simplifying like factors in the numerator and denominator. And so notice we have a x minus 3y in common in the numerator and denominator. I also notice that I have a 7 in the denominator and a 14, so 7 goes into itself once and 14 twice. So looking to see if I have anything else in common, I notice I have a y in my numerator and a y square in the denominator. So using rules of exponents, same base, subtract. There's more in the bottom, so if I cancel out one of these y's, or the y on top with one of the y's on the bottom. And so looking at this, all I have left in my numerator is this 2 times 2, which gives me 4, all over x, y times 3. So I'm just going to rewrite this as 3xy. Okay, so our answer is 4 over 3xy. Okay, so for the next problem, we want to simplify this rational expression. And so looking at it, we need to factor. Notice that 4x squared plus 4x minus 120, that has a 4 in common with both of those. So we can pull out a 4 in the numerator. And when we do that, we're left with x squared plus x minus 30. So in the denominator, I see that that's a trinomial, so I'm looking for two numbers that multiply to negative 15 and add to negative 2. And so those two numbers would be negative 5 and positive 3. So we can factor that as x minus 5, x plus 3. I also notice that my numerator could be factored a little further. And so I'm looking at what multiplies to negative 30 and adds to 1. And so that would be positive 6 and negative 5. So that would factor as the quantity x plus 6 times the quantity x minus 5, all over this x minus 5, x plus 6. So canceling now, since they're all factored in the numerator denominator, we can cancel like factors. Notice both of them have an x minus 5 in common. And both of them, sorry, that denominator should have been x plus 3. And so nothing else simplifies, and so our result is 4 all times the quantity x plus 6 all over, 4 times the quantity x plus 6 all over x plus 3. Okay, so for the next problem, we need to distribute. We want to use when I distribute. Sorry, a little bit, so I wanted to adjust it before I went on. So we're going to be distributing here x to the 2/3 power all times the quantity x plus 2x to the 1/3 minus x raised to the negative 2/3. Again, we're going to be using rules of exponents. Rules of exponents, they're same base. All of these are the same base, x. You add your exponents. Okay, so distributing. I also noticed that I could not add any of the terms inside this parentheses because none of them are like terms. So here we have x to the 2/3 times x. I'm going to rewrite this. This is the same thing as 3/3, just so that we had a common denominator there. Plus, here we have x to the 2/3 all times x to the 1/3, and then we have x to the 2/3 all times x to the negative 2/3. Okay, so adding our exponents, here we would have x 2/3 plus 3/3, this is 5/3, plus 2 times x to the 2/3 times 1/3, that's 3/3. Well, 3/3 is just 1, so just 2x. Minus x to the 2/3 times x to the negative 2/3. 2/3 minus 2/3, that cancels out to 0. So this is x to the 0 power. So this gives us the x to the 5/3 plus 2x, and then x to the 0 power is 1, so minus 1. Okay, so again, we are going to simplify the following expression, write your answers in the space provided. We're not going to do that. Rationalize all denominators, write complex numbers in the form a plus bi. So I noticed that in this number 6, 64 raised to the negative 2/3 power. We have a negative exponents. We want to rewrite that so it's a positive exponent. And so doing that, we can rewrite this as 1 all over 64 raised to the 2/3 powers. I'm just using rules of exponents. If it's negative and it's in the numerator, bring it down to the denominator, or vice versa. If you have a negative exponent in the denominator, we can bring it up to the numerator if it's a single term. Now I'm going to rewrite this as a radical. I notice that I have 64 raised to the 2/3 power. The denominator of the rational exponent is what root I am taking of that. So this is the same thing as saying 1 over the cubed root of 64 squared. That squared could be here, or I can pull it outside. Either way, it means the same thing. It's easier for me, I think, to pull it out because I know it is, because I can see what I can cube to get 64. Well, if I had squared 64 and then had to take the cubed root, it would be a bigger number and harder to see. And so here we have 1 all over. The cubed root of 64 is 4, and then we have this square out here. So we have 1 over 4 squared, which is 1 over 16. Okay, so division of complex numbers. To get rid of the complex number in the denominator, we want to multiply by the conjugate of the denominator. And the conjugate of a 3 minus 4i in this case is 3 plus 4i. So again, we're kind of multiplying by a fancy 1, so it's not changing our expression. Well, it is changing it, but it's in a different form. So we have 5i times 3, all times 5i times 4i. Well, 5i times 3, this gives us back 15i. And 5i times 4i, well, 5 times 4 is 20, so plus 20. All times I, which is I squared. So recall I squared is equal to negative 1. Or negative 1, or square root of negative 1 is I, by definition. Okay, so in the denominator, notice that's a factored form of a difference of 2 squares. So we could distribute this out, or this is the same thing as a minus b times a plus b, which is a squared minus b squared. So squaring our first term 3 minus squaring our second term 4i. So simplifying this down, we have 15i. I squared again is negative 1, so negative 1 times 20, so we're going to have minus 20 here. All over 3 squared is 9 minus 4i times 4i, so that's 16 times I squared, or the same thing as negative 16. So we're going to rewrite this so that the real part is first in the numerator, and so this is negative 20 plus 15i all over 9 minus negative 16 is 9 plus 16, which is 25. It wants this in a plus bi form. This is not quite an a plus bi form. I noticed that I could factor out now, or I can do it later. Let's just do it later. To put it in a plus bi form, let's rewrite this as 2 separate fractions. So this is the same thing as negative 20 over 25 plus 15i over 25. I can come out here. Let's reduce. So we have negative 20 and 25 have 5 in common, so that reduces down to 4/5, plus 15 and 25 have 5 in common, so that reduces to 3/5. Okay, so for 8, all we're doing is we're distributing. We have 3 times 1, all times 3 times 7i. Well, 3 times 1 is 3. 3 times 7i, this gives us 21i. Now distributing our 2i, we have 2i times 1, so this is plus 2i. And then we have 2i times 7i. Well, 2 times 7 is plus 14. I squared again is negative 1, so 14 times negative 1. We're going to want to combine like terms. And so I notice I have a 3, and 14 times negative 1 is negative 14. So 3 minus 14. 3 minus 14 is negative 11. And then I also have here a 21i plus a 2i. So this is going to give us plus a 23i. So simplify the following complex rational expression. So here's a case that we first want to rewrite this so that the negative exponents are positive. We need to be careful because there's more than one term in our numerator. And so when we rewrite this, we're only bringing down the piece that has the negative exponent. And we're going to just rewrite it like this. So 3x to the negative 1 power is the same thing as 3 over x. Plus y to the negative 2 power is the same thing as 1 over y squared. Well, this is our numerator. And then we're going to put this all over our denominator, 3x over y. So there's a couple ways to simplify complex fractions. I prefer to usually multiply by the LCD of all my fractions within the complex fractions. So if I look at my denominators, x, y squared, and y, I'm looking for that LCD. My LCD, in this case, is xy squared. Once you figure out what that LCD is, again, if you multiply by that fancy one, and this time the fancy one's going to be xy squared all over xy squared. The LCD are all values that our denominator are going to divide into that evenly, and so our fractions are going to disappear nicely. And so doing this, we have distributing this, the x is going to cancel, and we're going to be left with 3 times y squared. So 3y squared plus, so when we distribute this to the 1 over y squared, the y squared cancels and you're just left with the x. All divided by, so when we take xy squared and multiply it to 3x over y, one of the y's in the numerator is going to cancel with the y in the denominator. So we're going to be left with 3x times xy. Well, 3x times x is 3x squared and a y. This doesn't simplify down because of the addition in between the terms in the numerator. If that had been multiplication, then we could simplify further, but we can't in this case. Okay, so find the center and radius of the circle given below. Write your answer in the space provided. Okay, so for circle, we want to put it in the form that we can tell what the center and the radius is. In that form, we have the standard form for a circle is x plus h. Actually, it's x minus h plus y minus k. That x minus h is squared. This y minus k is quantity squared is equal to r squared, where hk is equal to the center and the radius is equal to r. It's not in this form, but we can manipulate it to be in this form. In order to do this, we want to rewrite this. We want to group all our x terms together and our y terms together. So doing that, we have x squared minus 6x. I'm going to put a spot here. Our whole goal is to complete the square on the x term, so that is a perfect square. So we're going to have to add some number in here to make it a perfect square. So let's just put that spot in there plus something. And then we have plus y squared plus 10y. Again, we're going to be adding something in this to make it a perfect square, is equal to 6. If we add something to one side of the equation, in order to make it equivalent, we have to add it to the other side. So we're adding the two numbers that we're going to make perfect squares for the x and the y term. In order to complete the square, we're looking for the same number that you would add to give you -6. We want to figure out what that same number is you multiply would go here. Well, the same number you add to get -6, that's -3. So -3 plus -3 is -6. -3 times -3 is 9. So to make this a perfect square, we need to add 9 on both sides. Same sort of idea, the same number that you would add to give you 10, you want to multiply that number together to give you what you're going to add to make that a perfect square. So the same number you add to get 10 is 5. So 5 times 5 is 25. So we just manipulated the x terms to be a perfect square. So you're thinking to yourself, again, what multiplies to give +9 and adds to give -6 is -3 and -3. So this could be rewritten as x minus 3 quantity squared. Plus, and so we can factor y squared plus 10y plus 25 as y plus 5 quantity squared is all equal to 6 plus 9, that's 15, 15 plus 25, that's 40. And so it's now in the form that we could be able to tell what we should be able to tell what the radius is and what the center is. So notice up here in the standard form of a circle, it's the opposite sign of what was inside the parentheses with those numbers. And so here, x minus h, it was h. So here, x minus 3, our x value of the center is going to be +3. And the y value, y plus 5 quantity squared, opposite sign, so -5. R squared is equal to what's on the other side when it's in this form, and so R squared is equal to 40. If we take the square root of both sides, usually put the plus or minus, but we're talking about distance, so we're not putting that in front of the square root sign. So just positive square root of 40. I notice I can break this down. 40 is 4 times 10, and 44 is a perfect square. So this could be broken down as square root of 4 is 2, and then we're left with a 10 underneath the radical. So our radius is 2 root 10. So sketch the graph of the following equations. Identify the asymptotes as dashed lines. Answer associated questions for each. So where is the y-intercept of f of x equals 3 raised to the x power minus 2? So we know that the x-intercept occurs when, where is the y-intercept? We know when the y-intercept occurs, it's when our value of x is 0. If you look any value on this y-axis, x is always 0. So to find the y-intercept, you're going to let x equal 0 and solve for y. Okay, so looking at this, f of 0, so wherever I see an x in my equation, I'm replacing that with a 0. So I have 3. I see that 3 is raised to the x, so I'm going to put a parentheses and replace that with 0 minus 2. Anything raised to the 0 power is 1. So 3 raised to the 0 power is 1. 1 minus 2 gives us -1. So we have a y-intercept at 0, -1. Okay, so let's look at plotting some points to see what else is going on this graph. If you're familiar with transformations, you can look at this as that -2 shifts the graph of y equals 3 raised to the x power down 2 units. Okay, so let's just plug in some numbers. If we plug in +1, I got 3 raised to the first power is 3, and 3 minus 2 is 1. So I have a point at 1, 1. If I plug in 2 there, I get 3 squared is 9, 9 minus 2 is 7. So I have a point at 2, 7. So let's look at what happens when we plug in a negative number. So if we plug in -1 there, we just do this on the side. This is the same thing as saying 3 to the -1 power minus 2. Well, 3 to the -1 power is 1/3 minus 2. We need a common denominator, which is 3. So I really have 1/3 minus 6/3 is -5/3. Well, -5/3, that's the same thing as -1 2/3. I'm just going to approximate that. So when x is -1, -1 2/3. So one more time, let's just try one other negative number to see what's going on. When we plug in -2, we just do this on the side. I have 3 raised to the -2 minus 2. So this is 1/3 squared, or 1/9, getting a common denominator. So this is -18/9, which is equal to -17/9. So this is -1 and 8/9. So I know what the shape of 3 raised to the x power is, and so just that -2, it's going to give me the general shape. Like I said, it was shifted down 2 units. So what's happening is this graph is getting closer and closer to the y value of 2 as x goes off to -infinity. So we actually have a horizontal asymptote here. It's a horizontal one, it's an equation, and so it's y equals -2. There's no vertical asymptote there, even though it looks like it's getting to become a vertical asymptote because it's so steep. Okay, so 12, y equals x squared minus 4x minus 5. So looking at this equation, it's asking me to graph it, and where's the vertex? So I can either complete the square and put this in vertex form of a parabola, or I can use the vertex formula. The vertex formula your h value, the x value of your vertex is equal to -b/2a, and your y value of that vertex, well, if you have an x value of a point, you plug that in wherever you see an x in your equation, and that gives you the y value of your point. So here I can see what my a value is. A is equal to 1, the coefficient in front of x squared, and my b value is equal to -4. So if I look at x, which is equal to the h value of my vertex, this -b/2a is equal to negative of b, which is -4, all over 2 times a, which is 1. So negative of -4 is +4, all over 2, which gives us back 2. So the k value of our vertex, which is equal to the y value of our vertex, and we're plugging this value that we just found, 2, back into wherever we see an x in our equation. So I'm going to go through wherever I see an x, I'm going to put a parentheses, and then I'm going to go back through and put that 2 there. So looking at my equation, I have x quantity squared, so I have a parentheses, that's going to be squared, minus 4, I see an x there, so I'm going to put parentheses instead of the x, and then minus 5. So wherever I saw parentheses, I'm just going to replace that with a 2. So simplifying order of operations, we have 2 squared is 4, minus 4 times 2, so minus 8 minus 5. So we have 4 minus 8 is -4, -4 minus 5, that gives me -9. So our vertex is at the point 2, -9. So when x is 2, y is -9. Okay, so looking at this, I want to figure out what my y-intercept is. Like we talked about above, our y-intercept occurs when x is 0. So if I plugged in 0 for x here, my x terms cancel, go away, and I just have -5 or -5. So I have a point crossing the y-axis at -5. I want to figure out what my x-intercepts are. My x-intercepts occur when my y value is 0. So my x-intercepts, we're going to let y equal 0. We have x squared then minus 4x plus 5 equals 0. So recall, this is a quadratic equation. Best way to solve it, if possible, usually the easiest, not necessarily the best way, if it's factorable. So there are two numbers that multiply to give you 5 and add to give you -4. Unfortunately not. And so I'm going to need to use my quadratic formula. So I know that x is equal to -b, so negative of -4, plus or minus the square root of b squared, so -4 times -4 is 16, minus 4 times a, which is 1, 4 times 1 is 4, times c, 5, is 20. All over 2a. So 2 times a, 2 times 1. Okay. So something is off. So negative b over 2a, negative 2. So let me just give you kind of the reason why I know something is off. My parabola, I can tell, is facing upwards because my coefficient of a is positive. That kind of tells me the direction of where my parabola is going, up or down. If it's positive, it's up, negative, it's down. Because my vertex fell below the x-axis and it's facing upwards, this is going to have to cross the x-axis. Oops, I see where I went wrong. I wrote down the problem wrong. So this is x squared minus 4x minus 5. Equals 0. Much nicer problem. This one actually factors. There's two numbers that multiply to give me -5 and add to give me -4. So x minus 5 all times x plus 1 equals 0. Set each factor equal to 0. X minus 5 is 0 and x is 5. And x plus 1 is 0 and x is -1. So we're crossing our x-axis at -1 and 5. I might extend this and ask you a couple other questions about this graph. I might ask you your axis of symmetry. If we're talking about axis of symmetry, that was the vertical line for our parabola that went through the x value of your vertex. If you folded your paper along this line, then it would be a mirror image across it. And so y or x equals 2 is your axis of symmetry. Looking at our range, so it really depends on where your vertex is and what direction your parabola is facing. If your parabola is facing up, it's going to be the y value of vertex and everything bigger than that. If your parabola faces down, it's going to be the y value of vertex and everything less than this. And so our range are all the y values we're hitting on our graph, which is everything that is greater than or equal to y -9. So I'm not going to go over number 13 because this is a sideways parabola, and this is something that we covered in the past in this course, but did not cover it this semester and is not in our curriculum anymore. Okay, so you're given functions f of x and g of x, and it wants you to find the following. So find the composite function of f of g of x. So this f of, this little circle in between, this is telling me that I'm plugging in my equation g of x wherever I see an x in f of x. So it could be rewritten this way. If it helps you, let's rewrite what g of x is. G of x is this whole equation, x squared minus 2x. So we're going to go back to our equation f of x, and wherever we see an x, we're going to put parentheses big enough so that we can replace it with this x squared minus 2x. So our equation f of x is x minus 3. So I see an x, put parentheses, and then we have a minus 3. So in our parentheses, we're going to replace it with g of x, which is x squared minus 2x. And so this is equal to x squared minus 2x minus 3. It didn't tell me how to factor it, so let's just put it here. So now it wants us to find f of g of -2. So there's a couple ways to do this. We already did the work, so let's just plug it into this. This is f of g of x. So to find f of g of -2, wherever we see an x in that composition function, we're going to go through and put parentheses. So we have parentheses, and then we have a square, minus 2. We have a parentheses because there's an x, and then a minus 3. Go back in, replace the parentheses inside with a -2, and then use order of operations to simplify. So we have -2 squared is 4. -2 times -2, so plus 4 minus 3. 4 plus 4 is 8. 8 minus 3 is 5. So then it asks us to find f of g of x, not f of g of x. It asks us to find g of f of x. So I'm going to do this on the side here. So this time, instead of taking the equation g of x and going in and plugging it in wherever we see an x in f of x, we're doing the opposite. We're taking the equation of f of x, which in our case is x minus 3, and now we're going to go in, and wherever we see an x in g of x, we're going to place parentheses there and then go put x minus 3 inside the parentheses. So we see an x, quantity squared, so we're going to put parentheses, quantity, and then a square. And then we see minus 2, and then we see an x, so we're going to put a parentheses there. Inside our parentheses, we're going to go in and we're going to replace that x with an x minus 3. Or in our case, just go into the parentheses and rewrite it as x minus 3. So we can simplify this a little bit. I can distribute out x minus 3 times x minus 3 to save some time. And if you did this, you would get x squared minus 6x plus 9. Be careful, you need to distribute that negative when you carry the 2 inside the parentheses. So -2 times x is -2x. And -2 times -3, that gives us a positive 6. So we have x squared. -6x minus 2x is -8x. 9 plus 6, this gives us plus 15. So g of f of x, this is x squared minus 8x plus 15. So for what values of x is g of x 8? Okay, so it's asking us, when is g of x equal to 8? So let's just work up here. So g of x is equal to 8. Well, g of x is x squared minus 2x. When is this at 8? Okay, so looking at this is an equation. I notice what type of equation it is. It's a quadratic equation, and so we want to get everything to one side of the equation, set it equal to 0. And so we have x squared minus 2x minus 8 equals 0. If possible, factor, which it is, two numbers that multiply to give us negative 8 and add to give us negative 2 is negative 4 and positive 2. So I'm looking at when is x minus 4 equal to 0? Well, that's when x is 4. And when is x plus 2 equal to 0? That is when x is negative 2. So now we're looking at finding the inverse of these functions. So looking at this, to find the inverse function, let's rewrite our function notation as y. So instead of f of x, this is the same thing as y equals the cubed root of x plus 5. In order to find the inverse, let's swap x and y. And so this is x is equal to the cubed root of y plus 5. Now we want to solve for y. We want to get y by itself, and once we get y by itself, that is our inverse function. So in order to get y by itself, we need to get rid of that cubed root. We can do that by cubing both sides of our equation. And so this gives us x cubed equals, well, the cubed root and the cubed cancels each other out, and you're left with the radicand, which is y plus 5. To get y by itself, we can subtract 5 on both sides, so we get y is equal to x cubed minus 5. And so let's just rewrite this in function notation. So this is f inverse is equal to x cubed minus 5. We can always show that a function and another function are inverses of one another by taking the composition. Either way, you should get back x. So same idea here. We're going to rewrite this as y equals 2/3 x plus 6. We're going to swap our x and y values. So this gives us x is equal to 2/3 all times y plus 6. We want to get y by itself, so if we subtract 6 on both sides, we get x minus 6 equals 2/3 y. We can think of this as multiplying both sides, or sorry, not multiplying, dividing both sides by 2/3, or we can think of it as multiplying both sides by the reciprocal of 2/3, so that makes it a coefficient of 1 in front of the y. So the reciprocal would be 3/2. So we get y, which is the same thing as f inverse of x, is equal to 3/2 all times the quantity x minus 6. If you want, you can distribute the 3/2 or leave it like that. Okay, so for the following, we want to graph the inequality solution, and we want to write our answer in interval notation. Okay, so nonlinear inequalities, we need to find our critical numbers. So critical numbers are the numbers that set this equal to 0 or where it is undefined. And so to find my critical numbers, I'm setting x squared plus x minus 12 equal to 0. quadratic equation, so we can solve this by factoring. Two numbers that multiply to negative 12 and add to positive 1 is a positive 4 and a negative 3. So x plus 4 is 0 when x is negative 4, and x minus 3 is 0 when x is 3. Once you find your critical numbers, you're going to place these on the number line. There's no number where x squared plus x minus 12 is undefined, so there's nothing that I have to look at there. So once you find your critical numbers, we're going to test numbers on either side of our critical number, plug it into our inequality to see if it's a true or false statement. And so let's look at something that's smaller than negative 4. So if we chose x equals negative 5 and we plugged it back into this inequality, we want to see, is this a true or a false statement? Would this be greater than 0? My computer just stopped, so let me pause this and come back. So again, we're plugging in negative 5 wherever we see an x in the inequality to see if we get back a true or false statement. And so is negative 5 squared, which is positive 25, minus 5, minus 12, is this number greater than 0? Technically, I really don't care what the number is. I just want to know if that's a true or false statement. And I noticed that when I sum and subtract those numbers, this is a positive number and it is greater than 0. It actually ends up being 8. And so this is true. And so I'm going to put a true up here on the left of negative 4. And so now you're going to try and plug in something in between negative 4 and 3. If 0 falls on that interval, that's the easiest one to do. If I plug in 0 wherever I see an x here, I'm just left with negative 12 is greater than 0. And this is a false statement. So I'm going to put an F here for false. One more number we need to try, so maybe x equals something to the right of 3. So how about x equals 4? So if we go back in, and wherever we see an x, we replace it with 4. So is 4 squared plus 4 minus 12, is this number bigger than 0? So we get 16 plus 4 minus 12. Well, 20 minus 12 is 8. 8 is bigger than 0. So this is true. So anything to the left of negative 4 is part of our solution. Anything to the right of 3 is part of our solution. And now we just need to determine is our endpoint part of the solution. And that depends on, is that a greater sign or a greater than or equal to sign. This does not have the equal to part, and these were the numbers that set it equal to 0, so we do not want to include them, so I'm going to put parentheses here. Or you can denote it with an open circle. And so our interval notation, we're looking at all numbers coming in from negative infinity until we hit negative 4, but not include it. So parentheses, union, we're hitting every number from 3 to infinity, not including 3, so a parentheses around that. Okay, so we're solving the following equations. So for rational equations, we can't have any value which gives us a 0 in our denominator. And so maybe just putting this here right now, what x cannot be. And so x cannot be negative 2. And x cannot be positive 3. These are the two values which give it on the denominator. Okay, so I have a rational equation. I can solve rational equations by clearing my fractions, by multiplying both sides of my equation by my LCD. if you look at this equation, notice that your LCD is equal to x plus 2, x minus 3. Okay, so the only reason we can clear the fractions here is because we're working with an equation and not an expression. And so with equations, if we do something to one side of the equation and do it to the other, then we should get an equivalent solution. So I'm going to multiply x plus 2 times x minus 3, that quantity, to both sides of my equal sign. Again, we chose the LCD because we knew our denominator would divide evenly into this, clearing our fractions. And so notice that our x plus 2's cancel. And so on the left, we're left with the quantity x minus 3 times x. I'm going to distribute my x here. And so distributing my x, I get x times x is x squared, and x times negative 3, so minus 3x, is equal to, on the other side of my equal sign, my x minus 3 cancels, and I am left with 5 times x, the quantity x plus 2. So 5 times that quantity, 5 times x is 5x, and 5 times 2 gives us plus 10. So looking at what type of equation I'm left when I clear my fractions, I have a quadratic equation. So the goal is to get everything to one side. If I subtract 5x on both sides, I have x squared. Well, negative 3x minus 5x, that's negative 8x. And I'm going to subtract 10 on both sides of my equal sign is equal to 0. Okay, so I'm looking for something that multiplies to give me negative 10 and adds to negative 3. So unfortunately, I don't see those numbers, and this is where I can either complete the square or I can use my quadratic formula. So negative b, negative of negative 8 is positive 8, plus or minus the square root of b squared, negative 8 quantity squared is 64, minus 4 times a, so that's negative 4, times c, negative 4 times negative 10, so that's plus 40, all over 2 times a, well, 2 times 1. So this gives us x is equal to 8 plus or minus the square root of 104 all over 2. So I'm curious if I can pull anything out from underneath that radical, if there's a factor of 104 that's a perfect square. If you can't see if it's a perfect square or not, factorizations. So I'm looking, are there two numbers or something that occurs a factor twice? So let's break this down. I noticed that 4 probably goes in there. 4 goes into 10 twice. That gives me 8. And so I'm left with 2, and so 24. 4 goes into 24 26 times. So I noticed 26 doesn't have a factor that's a perfect square. So let's break this down. We get x is equal to 8 plus or minus, well, the square root of 4 times 26. Square root of 4 is 2, and then we have left with square root of 26 all over 2. I notice that I have a factor of 2 in common in my numerator. I can pull that out, and that would leave me with a 4 plus or minus root 26 all over 2. So now that I factored out that 2 in the numerator, I can cancel it within the denominator, and we're left with our answer. X is equal to 4 plus or minus square root of 26. This is not negative 2 or 3. This does not set my denominator equal to 0, so this is my solution. Okay, so solving equations with radicals. Solving equations with radicals, you want to get the radical to one side of the equation, done. Then we want to raise both sides of the equation in order to get rid of that radical. So if it's a square root, we're going to square both sides. If it was a cubed root, you're going to cube both sides. If it was a fourth root, you're going to raise both sides to the fourth power, etc. So squaring the square root of 3x plus 1, that cancels the radical, and you're left with a radicand 3x plus 1 is equal to be careful here. We need to distribute out x minus 1 times x minus 1. I can't just square each term in there because there's more than one term. You have to distribute that out. And so left-hand side, I get 3x plus 1 is equal to, so distributing and combining like terms, you should get x squared minus 2x plus 1. I have a quadratic equation. I'm going to get everything to one side and set it equal to 0. And so if I subtract 3x on both sides, that would give me negative 2x minus 3x is minus 5x. And then subtracting 1 from 1, that cancels, equals 0. So quadratic equation, I notice this is factorable. They both terms have an x in common. We can pull out the greatest common factor of x. Doing that, we're left with x minus 5. And so there's two values which would set this equal to 0 when x is 0 and when x minus 5 is 0. And that is when x is 5. Okay. You need to be careful if you raise both sides of your equation by some power and it's an even power, you need to check your solutions or your answers. You might get what are called extraneous solutions, so answers that actually don't work when you plug it back in. So if we plug in 0 back into this original, we want to see we get a true statement. I notice when I plug 0 in here, I get the square root of 1, which is 1. Is that really equal to 0 minus 1? Is 1 equal to negative 1? It's not. So this one does not work. So now let's try 5. 3 times 5 is 15 plus 1 is 16. So the square root of 16 is 4. We want to make sure that's the same thing as when we plug 5 over here. Where are we going to get 4? 5 minus 1 is 4, and that does work. So we only have one solution, x equals 5. Okay, so for the next one, we can use substitution. We can try to factor that. Let's look at this, 4 times 2. I'm using my AC method here because my number in front of my square, I'm going to think of this as a square, it's not really, is not 1. So 4 times 2, that's 8. You're looking for two numbers that multiply to 8 but add to give us the middle term, b, which in our case is negative 9. And so I think to myself, are there two numbers that work, that multiply to give me 8 and add to give me negative 9? And yes. How about negative 8 and negative 1? So once you've found those two numbers, you're going to rewrite your original problem with a middle term using the two numbers you found. Let's rewrite that middle term using those. And so this is the same thing as minus 8t squared minus 1t squared, and then a plus the 2 equals 0. Okay, so if I summed those two middle terms, I would get back this. The point is of doing this, we can use now factoring by grouping. And so if we look at what the first two terms have in common, that is a 4t squared. If we pull out a 4t squared, from the first two terms, you're left with what? You're left with a t squared minus a 4. No, minus a 2. So looking at t squared plus 2, see what they both have in common. We actually want the same thing inside the parentheses. So if we factor out a negative 1, that also would leave us with t squared minus 2. So the whole point of that, if this AC method works, what's inside the parentheses could be the same or can be manipulated to be the same. So we have t squared minus 2, all times the quantity of 4t squared minus 1 equals 0. So we're looking at when is t squared minus 2 equal to 0? Well, if we add 2 to both sides, when is t squared equal to 0? Sorry, add 2 is equal to 2. use your square root method. So t equals plus or minus the square root of 2. We're also looking at when is 4t squared minus 1 equals 0. Couple different ways we can do this. We can use your square root method, isolate your square. I also notice that these are difference of squares. So this factor is at 2t minus 1, 2t plus 1. Set each factor equal to 0 and solve for t. So if we add 1 and divide by 2, t is going to equal 1 over 2. If we subtract 1 and divide by 2, t is equal to negative 1/2. So we have 4 solutions that work. Plus or minus root 2 and plus or minus root 1/2. Okay, so now we're looking at the quantity 2x plus 3. That quantity squared equals 18. I notice that I can either distribute all that out, it's quadratic, get everything to one side of the equation and try to factor, or I notice I can use the square root method, and that would be a lot faster. And so we could get rid of that square by taking the square root of both sides. And so doing that, we get see if she'll write 2x plus 3 quantity squared. The square root of that is equal to plus or minus the square root of 8t. Okay, the purpose of taking the square root of both sides was to cancel that square, and so we're left with 2x plus 3 equals, I notice that there's a perfect square that's a factor of 18, so I'm going to break down plus or minus square root of 9 times 2. I need to isolate my x, subtract 3 on both sides. I get negative 3 plus or minus, pulling out the square root of 9, which is 3 root 2. Divide both sides by 2, we can get x by itself, so x is negative 3 plus or minus 3 root 2 all over 2. Okay, so logarithms. Solving a log equations, you want to get all your logs to one side of the equation and your constant to the other side. Already done. If you have more than one log, you want to use properties of logs to rewrite this as a single log. If you have minus in between the two logs, that is division. So this could be rewritten as log base 2 of x all over x minus 1 is equal to 3. Okay, so now once you got a single log equals the number, we can use the definition of logs to rewrite this in exponential form. So our base of our log is the base of our exponent. So we have 2. What is on the other side is our exponent. So 2 cubed equals x all times x minus 1. All over x minus 1. 2 cubed is 8 equals x all over x minus 1. Let's clear the fraction by multiplying by x minus 1 on both sides of the equation. Let's distribute that 8. We get 8x minus 8 is equal to, whole point was that to go away, x. I notice this is a linear equation, so I approach this a little differently solving. I want to get all the terms with x on one side, so if we subtract 8x on both sides, we get negative 8 equals x minus 8x is negative 7x. Divide both sides by negative 7. We get x is equal to, well, negative 8 over negative 7. The negatives cancel, and it's positive 8/7. Okay, so dealing with log equations, we need to make sure that our solution is in the domain of logs. We can't take a log of a negative number. So if I plug in 8/7 wherever I see an x, I need to make sure it's a log of a positive number. Log of base 2 of 8/7, that's positive. Log base 2, well, 8/7 minus 1. 8/7 is bigger than 1, so this is a positive number. I checked it. We're good. That's our solution. So natural log of x minus 2 equals 3. So let's rewrite this in exponential form. So natural log is log base e. So the base of our log is the base of our exponent. So this is e. This is e, all raised to the 3 power is equal to x minus 2. So to get x by itself, let's just add 2 to both sides. We get x is equal to e cubed plus 2. So that's an exact form, and so, or the exact answer. You can leave it like that, or we can put it in the calculator and put it in decimal form. Okay, so solving this rational equation. Again, rational equations, you got to be careful of values which set the denominator equal 0. So notice here that t cannot be, well, t plus 3 is 0 when t is negative 3. T minus 4 is 0 when t is 4. Notice that this factors. Two numbers that multiply to negative 12 add to negative 1, so that's a negative 4 and a positive 3. So rational equations, we can multiply both sides by our LCD. Our LCD in this case is t minus 4 and t plus 3. So we got to distribute that to each term inside on the left. When we distribute that, the t plus 3 is going to cancel for the first grouping, and we're going to be left with the quantity t minus 4. Plus, when we distribute it to the second grouping, the t minus 4's cancel, and you're left with a 2 all times the quantity t plus 3. Is equal to, when we distribute to the other side of the equation, which we have to do, just think of it as doing it to both sides of the equation, the t minus 4 and the t plus 3 cancels, and you're just left with the 14. So let's distribute the t, we get t squared minus 4t. Let's distribute the 2, we get plus 2t plus 6 equals 14. It's a quadratic equation, so let's get everything to one side of the equation. We have t squared. While we're doing that, let's combine like terms. So I have a negative 4t plus a positive 2t. That's a negative 2t. And if I subtract 14 on both sides, I have 6 minus 14 is negative 8. I'm looking at when is this equal to 0? This factors. So there are two numbers that multiply to give you negative 8. And add to give you negative 2, which is negative 4 and positive 2. So in this case, t is equal to positive 4. T minus 4 is equal to 0 when t is 4, and t plus 2 is 0 when t is negative 2. This is where I said you had to be careful. Notice that t cannot be these values. So t cannot be 4. And so t is only equal to negative 2. Okay, so solving systems of equations for all real numbers. So this was something that we didn't get a chance to go over in this class, and doing 3 equations, 3 variables. And so we're not going to go through that right now. And you don't have to worry about it on the final. Same thing here. This is a nonlinear systems of equations. This actually is not covered in this course right now anymore. And so we're not going to cover that. Sorry. We revamped this course a few years ago. Let's see if there's anything else. So we've got a couple word problems to go through. So working together, Paul and Art can build a bridge for a landscaping project in 4 hours. Working alone, it would take Paul 15 hours longer than Art. How long would it take Art to build a bridge working alone? Okay, so working alone, it would take Paul 15 hours more than Art. So let's say Art can do the job in X hours. So if that's the case, and it takes Paul 15 hours longer than Art, Paul can do the job in X plus 15 hours. Okay, so this is a work-related problem, and so I know that 1 over the time it takes one person to do the job, which is X, plus 1 over what it takes another person to do the job, which for Paul is X plus 15. And I would continue to do this until I got to all the people working, which is just Paul and Art in this case, is equal to 1 over the time it takes them to do the job together, which in our case is 4. So I have a rational equation. We want to clear our fractions. We can multiply by the LCD. So looking at my LCD of X plus 15 and 4, that's going to be 4X all times the quantity X plus 15. So what we do to one side of the equation, we need to do to the other. Okay, so X cancels here when we distribute, and we will be left with a 4 all times the quantity X plus 15. Plus, so when we distribute it to the second grouping, the X plus 15s cancel, and you're just left with a 4X is equal to, and on the other side, the 4's cancel, and you're left with X times the quantity X plus 15, or distributing that X as X squared plus 15X. So I know this is a quadratic equation, so we want to get everything to one side, but before we do that, let's distribute that 4 and simplify. So 4 times X is 4X, 4 times 15 is positive 60, so 4X plus 60 plus 4X is equal to X squared plus 15X. So we have 8X, because 4X plus 4X is 8X, plus 60 is equal to X squared plus 15X. Again, looking at what type of equation I have, it's quadratic, so we want to get everything to one side of the equation. So let's subtract 8X on both sides. We would have X squared plus 15X minus 8X, so that's plus 7X, and then minus 60 equals 0. Okay. So we're looking to see, is there two numbers that multiply to give us negative 60 and add to give us 7? So 4 and 15 is not going to work. 12 times 5 works. And so that would be a positive 12 and a negative 5. So X plus 12, X minus 5 equals 0. So we're looking at X equals negative 12 and x equals 5, setting each factor equal to 0 and solving. And so notice that this is an application problem, and so you need to make sure that your answers make sense. And we have -12 as an answer. Can art do the landscaping job in a -12 hours? Well, that doesn't make sense, so no. But art can do the job in 5 hours. And Paul can do that job 15 hours longer than art, so this would equal 20 hours. So for art to build that bridge for the landscaping, it's going to take him 5 hours to do it alone. Okay, so we got a crudely built potato gun. We'll launch a potato such that the height after launch will be given as the following. H of t equals -16t squared plus 112t plus 8 feet. What is the maximum height of the potato reaches? Okay, so we're dealing with a quadratic equation. So I know quadratic equations, the graphs are either going to face up or they're going to face down. If it's facing down, I notice my vertex is the maximum. I can tell that my parabola is facing down because my a value equals -16 and it's less than 0. So we need to find the vertex. So the h value of the vertex, again, is -b/2a. So this is negative. My b value is 112 all over 2 times -16. So this is -112 all over -32. Let's see if that goes in evenly. And that would equal 3.5. Okay, so the h value, in this case, we know the max is going to occur at 3.5 seconds. That doesn't tell me what the maximum is. In order to find the maximum, what I have to do is I need to plug in this result, 3.5, wherever I see a t in this equation. So I have -16, I see a t, so instead of putting t, I'm going to put a parentheses and then square, plus 112 times t, so instead of t, put a parentheses, plus 8. So inside the parentheses, put 3.5. So we have 3.5 squared, which is 12.25 times -16. This gives you -196. 112 times 3.5, this gives us 392, so plus 392 plus 8. So I get -196. I notice these are two positive. 392 plus 8 is 400. And so this is equal to 204 feet is the max height. Okay, so I think, oh no, we're not done. The test just keeps on going. So, the golden, or the bank of gold man sucks. I don't know if I pronounced that right. It's getting late. The Bank of Goldman Sachs offers an investment that pays 2.3% per year, compounded continuously. For each question below, use compound interest formula A equals PE raised to the RT. If you invest $3,000, so I know that's my initial amount, which would be my p-value. What will the investment be worth in 2.5 years? So this is my t-value. Round your answers to the nearest dollar. So this is pretty much a calculator problem. Our amount's going to equal our initial amount invested, which is 3,000, all times E raised to the RT. Oops, and our interest rate. Our interest rate here is 2.3%. We want to put this in decimal form, so 0.023. 0.023 times T, and T is 2.5. So make sure when you're plugging this in the calculator that you have parentheses around that whole exponent. And so I have 3,000. I'm taking E and I'm raising that to the 0.023 times 2.5. And this gives me a result of approximately, rounding to the nearest cent. Oops, they told me the nearest dollar, so let me readjust what I was going to say. This is $3,178. Okay, so in 2.5 years, the amount in the bank account is $3,178. Then we want to know how long it will take 3,000 to grow to 4,500. And so this time we have the amount, we just don't have the time. And so almost the same equation, but this time the amount is 4,500. We want to know, when is this equal to 3,000? E raised to our interest rate of 0.023 T. Okay, so I have an exponential equation. I want to isolate my exponential piece. I need to divide both sides by 3,000. So I notice that this simplifies a little bit. I can divide both 4,500 and 3,000 by 100. Then I notice 45 and 30 both have a 5 in common. 5 goes into 45 9 times. 5 goes into 36 times. That actually reduces more. E to the 0.023t. They both have 3 in common. So this gives me 3/2 equals E to the 0.023t. So once you've isolated the exponential piece, you want to take the log or natural log of both sides. In this case, we're going to want to take the natural log of both sides because the natural log of E just gives us back our exponent. So we get the natural log of 3/2 equals, well, we're thinking to ourselves, what can we raise E to get back this piece E raised to the 0.023t, which is 0.023t. Divide both sides by that 0.023. Rounding to the nearest tenth. So you're going to do the natural log. 3 divided by 2, close your parentheses, divided by 0.023. So this gives me 17.62, but to the tenths, that 2 keeps the 6 the same. Seems like a long time. We can always check it, just because that to me seems like a long time. What would happen if I plugged in, instead of 2.5 up into this equation, that's 17.6. If I do that, I get back $4,497, which is basically 4,500. We did estimate it with decimals. Okay, so the stopping distance of a car varies directly with the square of the car's speed. Okay, so stopping distance varies directly with the square of the car's speed. So maybe we can call it D for distance. When you see varies directly, we put equals. We always have this K times here. And then it says varies directly with the square of the car's speed. So speed, maybe call it R for rate, R squared. Okay, so now it's going to give us enough information to plug in for D and R so that we can figure out what K is. And so now it says a car traveling 65 miles per hour, that's our rate, requires 212 feet to stop. So we have 212 is equal to K times 65 quantity squared. So we have 212 is equal to K times 65 squared. Gives us 4,225. So K is 212 divided by 4,225. So now we have our distance formula. I'm not going to reduce, I'm just going to put it in here. I'm not sure if anything, if they have anything in common. So now here is the equation. We can answer anything they throw at us. If they give us distance, we can find this rate. If they gave us the rate, we can find the distance it would take to stop. So what distance would be required to stop the same car that is traveling 80 miles per hour? Okay, so our distance here, we're trying to figure out when it's going 80 miles per hour. So our distance here is equal to our 212 over 4,225 all times 80 squared. So that would be 6,400. So D, round your answer to the nearest tenth of a foot. Okay, so D is approximately, well, I have 321. But, nope, it says tenths, so yeah. So I have 321.13, so this is going to be 321 point, that 3 keeps the 1 the same. So it's going to take them, when they're going 80 miles per hour in this car, it would take them 321.1 feet to stop that car. Okay. Okay, so we made it through one of the previous finals given at Yuba College a while back, gosh, 6 years ago. So hopefully this is helpful and good review questions for you to look at and help you study for the final.